Hello students, today I shall discuss about acetic acid or ethanoic acid or CH3CHH or C2H4O2. You will have to remember this formula of this compound too. So let us start. First, 5 to 8% dilute aqueous solution of this compound is called vinegar. Next, it has boiling point 118 degrees centigrade. Since it is an acid, its taste will be sour. It is sour in taste. It has pungent smell. It is totally soluble in water. And in cold country, acetic acid is also called as glacial acetic acid. Why? Because at about 17 degrees centigrade, cold country, at about 17 degrees centigrade, this acetic acid freezes and attains a crystalline shape. This is why acetic acid is also called glacial acetic acid. These are some physical properties, and we'll move to the chemical properties of this compound. First, acidic nature. How will you judge this compound is an acid? Take a litmus paper. Suppose here we have the aqueous solution or simply the acetic acid solution, CH3COOH. Now put a litmus paper here. What will happen? This litmus paper is of blue color. Now when you place it in acetic acid, it will changes its color from blue to red, indicating this will be an acidic substance or acidic solution. So when you place a litmus paper in the acetic acid solution, then blue litmus paper, it changes its color from blue to red. Again, when acetic acid is placed in water, it is dissociated as CH3COO- plus H+, acetate ion and hydrogen ion. So you can conclude from here that acetic acid is also an acid. Next, reaction with metal. Let us discuss the reaction of acetic acid with sodium metal. When acetic acid is treated with sodium metal, a little heat you can also give. So it will form hydrogen gas and corresponding salt, sodium acetate, with the liberation of hydrogen gas. For the valence, you need 2 here, 2 here, 2 here. This is called sodium acetate with the liberation of hydrogen gas. Now, if you place a burning candle or burning matchsticks over the container where hydrogen is liberating, it will burn with pop sound. Indicating that is hydrogen gas. So if for the reaction this pop sound is generated by placing a burning matchstick, and if pop sound is generated, we can conclude that this is an acid. Next is reaction with bicarbonate salt. When acetic acid is treated with a bicarbonate salt, let's say sodium bicarbonate, that is NaHCO3, what will happen? First, sodium salt of acetic acid CH3COONA plus carbon dioxide gas will be released and water will be formed. Here a brisk effervescence of carbon dioxide will be observed when acetic acid, suppose acetic acid, we have acetic acid here and you place solid sodium bicarbonate salt in this solution. What will happen? A brisk effervescence of carbon dioxide will be observed. That is, by this we can conclude that this is an acidic, this compound contains an acidic functional group. Next, reaction with carbonate. Same reaction, CH3COOH plus Na2CO3. Here I take sodium carbonate. When treated, same product will be obtained. That is CH3COONA plus carbon dioxide gas plus water. Both the cases, same product will be obtained. But since here there is 2 sodium atom, so for the balance we have to give here 2 Na, and for the here we have to give 2, and here is also 2. Now this is balanced. Next, reaction with alcohol. Here we take ethanol. What will happen if acetic acid CH3COOH is treated with ethanol in presence of concentrated sulfuric acid under little heating condition? What will happen? And water molecule will be removed from here. What the product will obtain? The product will be CH3COO CH2CH3 plus water. This is called an ester. This compound is an ester, and this is ethyl acetate. Here you are saying sodium acetate, so here there is ethyl group, ethyl acetate, and ester is formed. Very sweet smell, ester. Sweet smell. Ethyl acetate. This reaction is called esterification reaction. And it is also discussed when we discuss about ethyl alcohol. Next, what happens if an ester CH3COO CH2CH3, this compound is hydrolyzed in presence of base, let's say that is NaOH. If an ester is hydrolyzed in presence of base, then what product is obtained? Then the sodium salt of the acid is obtained and the original alcohol is produced. Sodium salt of this part is connected, this and this, and this will be another. This will be another CH3CH2OH and CH3COONA. This reaction is called saponification reaction. This reaction is called saponification reaction. The hydrolysis of an ester in presence of base is called saponification reaction. Again, you also know that when an acid CH3COOH is treated with sodium hydroxide in presence of calcium oxide heating condition, then what product is formed? And methane gas is formed. CH4. This mixture is called soda lime. This mixture is soda lime, and this reaction is called decarboxylation reaction. This reaction is called decarboxylation reaction. Decarboxylation reaction. Okay, so let us conclude up to this that acidic nature by litmus, as well as treating with water, hydrogen ion liberation. Reaction with metal, hydrogen gas is formed. Bicarbonate, in case of bicarbonate, sodium salt of that acid, carbon dioxide and water is formed. Same reaction is also happened when reacts with carbonate, but balance will be different. Next, the esterification reaction and saponification reaction and decarboxylation reaction. So we'll move to the next point. So take a quick screenshot of this part. Okay. Next. Next we have reduction reaction. 5, 6. Reduction of acid. What happens when an acid CH3COOH is reduced by reducing agent like lithium aluminium tetrahydrate, LiAlH4, lithium aluminium tetrahydrate. This compound is reduced. That means hydrogen will be added in this compound. So this will be converted to CH3CH2OH. On reduction, an acid is converted to the corresponding alcohol with same number of carbon atom. So this is the reduction. When ethyl alcohol is reduced by when acetic acid is reduced by a reducing agent, lithium aluminium tetrahydrate, then ethyl alcohol is formed. Next is HVZ reaction. Next is HVZ reaction. What is this? HVZ is, according to the scientist Helvoland-Jelinek, when an acid, that is like CH3COOH, is treated with red phosphorus in presence of halogen like Br2, Cl2, etc., it will form alpha halo derivative of the acid. This is acetic acid and this is the functional group. With respect to the functional group, this is alpha carbon and the product will be alpha halo acid. That means one halogen atom will be placed in alpha carbon. So for that, one hydrogen must have to be removed. So the product will be CH2, one hydrogen will be removed or eliminated, and in that case, for that hydrogen atom, one halogen atom, here we use bromine, Br will be added, and the acid functional group CH3, this is alpha halo acid. Here we can say this is alpha bromo acid. If you take this example, CH3, CH2, COOH, under same condition, this is the alpha carbon, so one halogen atom will be added in alpha carbon and one hydrogen atom will be eliminated. This is alpha bromo acid. This is also alpha bromo propanoic acid. So next, our next reaction is next reaction is Hans-Sticker reaction. Diecker, Hans-Sticker reaction. This is acetic acid CH3COOH. When this hydrogen atom is replaced by silver atom, silver chloride. You know silver chloride. Silver has +1 oxidation state, and hydrogen also H plus and Ag plus. When this hydrogen atom is replaced by this silver atom, then we'll get silver salt of acetic acid. Silver salt of acetic acid. When this silver salt of acetic acid is treated with bromine, when this silver salt of carboxylic acid is treated with bromine Br2 in presence of carbon tetrachloride, it will form CH3Br plus carbon dioxide gas plus AgBr. In the reactant there are 2 carbon atoms, but look at here in the main product, that is haloalkane. This is haloalkane is formed. This is haloalkane, that is halogen derivative of alkane is formed. Here 2 carbon atom, but in the product there is 1 carbon atom. This is called Hans-Sticker reaction. When silver salt of carboxylic acid is treated with bromine in presence of carbon tetrachloride medium, then haloalkane derivative is formed. That is here methyl bromide is formed, and a carbon dioxide gas is released, and AgBr is also formed. So the side products are not so important in organic chemistry. Here main product is haloalkane, methyl bromide is formed. So these are about all reaction of acetic acid. And there is another question is likes to come: how will you identify this is an acid? So for that, you first test will be your litmus paper test. Second test will be the reaction with metal, sodium metal. You can also test with brisk effervescence, that is carbonate, metal carbonate or metal bicarbonate. And most important test is the esterification test. By esterification test, you can conclude that this is an acid by its sweet smell so generated on the reaction. So that's all from acetic acid. Thank you. Have a nice day.